So if we look at a time complexity in terms of n versus log n versus n squared versus n log n, right? Log base 2. We can see that as we increase number n, log n, n squared, and n log n, shows the growth. So by and large, log n, right, obviously is the best, but there is no such thing as log n, right, for sorting algorithm. There is log n, right, for search, for perhaps some insertion operation, deletions, or maybe even retrieval, depending on the data structures that you have, that you would want to apply these operations. But in terms of sortings, you would have n, you have n squared, and obviously, the next step up is n log n. As n increases, n log n also increases, but not as much. Obviously, you wouldn't not want to have this, right? This is what we call a quadratic exponential growth. Log n is what we call logarithmic. N log n is also logarithmic, but this is the best we can get. I believe there's maybe one or two more efficient sorting algorithms, but their sorting algorithms are beyond the scope of this this course. So for the purpose of this course, our more advanced sorting algorithms all have n log n. So this is the piece, including the merge sort algorithms that you just reviewed. So let's move on to the next page to talk about merge sort. As you remember, the merge sort is a sorting algorithms, right, that divides an array into two halves, recursively sorts each half, and then merges the sorted halves to produce a sorted array. Merge sort uses two methods, right? Merge and merge sort. Well, the issue with merge sort is and this is used, when we do divide and conquer, is that now you have this recursion. At the end of the recursion, when you're done sorting the left and right side, what we have is what we call merge, right? The merge method merges two sequential sorted partitions within an array and has several parameters. And one of the most important aspect of this, the merge sort, is it requires some space. That temporary space, or the final array where you need to have all of the elements sorted, is an extra sorting space. There's no way, right, we can do the sorting of the elements in place, right, within the original array. It simply doesn't happen with merge sort. So one of the disadvantages for merge sort is if the size of the array is very big, and space is limited on your computing devices, and this is not an appropriate choice. We're going to look at the others. Actually, there are several n log n sorts out there, namely quick sort, heap sort, radix, so on and so forth. They do not involve moving elements around, from one array to another, requiring auxiliary array to hold them. You can simply do them in place. So these are more preferred advanced sorting that we will be discussing in the next chapter.